Muscles don't recover as easily with age. Now, scientists at Duke-NUS think they found a key reason why, and it happens on the cellular level, and it's linked with a gene called DEF1. Now, to tell us more, we have two of the scientists here from the Cancer and Stem Cell Biology program at Duke-NUS, Assistant Professor Dr. Tang and Dr. Kenon Chua, who is also an orthopedic surgeon with SGH. Thank you both for coming here and joining us today. Interesting topic. Dr. Tan, first to you. Your team has zoomed in on what we just told our viewers is the DEF1 gene. Now, for our viewers at home, what is the role that it plays in our muscles and how does that change as we age?
So the DEF1 is actually the transcriptional factor that can help muscle to control how they grow and how they repair themselves. So in young and old muscles, the DEF1 can maintain this process is well organized and well balanced. So muscle can stay strong and healthier. But when we age, the DEF1 activity and expression levels start to increase. That means instead of supporting repair, the DEF1 start to inhibit or suppress the muscle maintenance and regeneration. So over time, this contributes to the aging-induced muscle loss, or known as sarcopenia, making muscle weaker and take long time to recover.
Okay, so DEF1, bad.
DEF1, too high is bad.
Too high is bad. Now, we always hear, exercise is good, but your study also shows what exercise is doing inside the muscle on a cellular level. So can you explain to us why that's important to know?
So we find that actually exercise is like a brake for the aging muscles. It can decrease the DEF1. It can slowly decrease the DEF1, so it can maintain the DEF1 level back to normal. So that can make the muscle close to the heavier again.
Right, so it keeps DEF1 at bay in that sense, exercise.
Right.
Maybe bring you in here, Dr. Chua. Muscle loss, it's gradual.
Yes.
We understand, but it can also have real consequences. In your line of work, why does muscle strength matter so much for independence as we get older? And also, why should we start caring about it when we're young?
Thank you very much for the question, Jill. I think muscle is important because the muscle is not just important for mobility and locomotion. It's also important for balance and to prevent falls. So as we age, there's an increased risk of falls. It also acts as almost like a reservoir for secreting specific signaling molecules to maintain brain health, to reduce cardiovascular disease, and also to improve insulin resistance. That means prevent diabetes. So having healthy muscle is very important for all these functions. So why do we want to encourage young people to start exercising early? The reason is because you think of muscle like a bank account. You want to improve the muscle quality and volume so that as we age, even if there's a decrease, it doesn't drop to a very low level, which results in a pathological process, which you mentioned.
So put your deposit in now.
Yes.
Yeah. Okay. And, in terms of weaker muscles, what does it look like when it comes to older patients, especially when they fall, they have injuries, or even after surgery? And how does it affect everyday things like even getting up from a chair?
Yeah, so I think as our Singapore population ages, we see more and more patients who have problems like fragility fractures. And we find that patients who undergo surgery, if they have good muscle mass to begin with, their recovery is much faster. That means they are able to recover from surgery faster and mobilize faster. Whereas those who have poorer muscle mass, they take a long time to recover. And as we know, the more immobile the patient is, the more complications they have. For example, they can get chest infections, blood clots in the legs, and even urinary tract infections and bed sores. So our objective as doctors is always to mobilize the patient early so that they can maintain their healthy lifestyle and prevent complications.
All right, bring you in again, Dr. Tan. We hear older adults say, this could be me. I exercise, but I still feel sore and I don't see results. Does your research help to explain why some people seem to respond better than others? And what does it mean for the way we train, the kind of exercises we select?
Yeah, so that's very important issues. So our current research actually find that not all the aging muscle or not all elderly people responds to the exercise in the same way because of the underlying molecular differences. So, so by identifying the genes or pathways like DEF1 involved in this process, we can start to predict who can actually benefit less from the exercise alone. And that brings into the treatment, right? So we start to look into how to manipulate the DEF1 using the scientific way, like the adenovirus. We can use the virus to deliver the DEF1 or DEF1 RNAi try to manipulate the DEF1 levels in the muscle specifically. So this can manipulate. This can make the muscle recover better. Yeah.
Would you like to jump in on that? On the fact that we understand DEF1, how is that going to change the way we exercise, or what might treatments look like in the future?
Yeah, I think that's an excellent question. We know that DEF1 levels, too high is bad, too low is also bad, and we want to maintain it at the optimal level. We also know different types of exercise regimes result in different effects on DEF1, mTOR1 pathway. So for example, if you do more resistant type exercises, you increase DEF1 and mTOR1. But if you do more aerobic exercises like what my friend has said, then you have a decrease in terms of DEF1, mTOR1. So by changing the exercise regime, you can actually maintain the DEF1 at the optimal level. And like my colleague also mentioned, you can have different types of treatments. For example, this allows us to investigate whether certain drugs will be able to be individualized for the patient who has either high or low DEF1 or mTOR1.
So a lot of potential then.
Yeah.
Yes.
So I believe this will be in the future, this will become in the personal medicine for sports or for the muscles.
Customized, huh?
Customized drugs.
Okay. Well, thank you very much for opening this whole new world to me, because now it's aerobic exercises versus strength. But thank you so much for both of you coming in and sharing that with us. I've been speaking there with Duke-NUS representative, showing us how exercise can help aging muscles repair at a very cellular level.